video, we are learning antiderivative of a function, or called as also integral of a function. So let's first see the definition. If derivative of a function called capital F equals a given function little f, then this capital f of x is called the antiderivative of little f, denoted as this. So in this notation, we have this S-shaped sign called integral sign. The function itself inside the expression is called integrand. So we read this result as integral of f equal to f of x, capital F of x, right? Left side is integral notation. So basically this is just same as saying the antiderivative of little f is capital F, all right? Now by definition, you can tell if you find one function as the antiderivative, then this function plus c is also antiderivative, because it makes no difference. If you have capital F plus c differentiated, it's the same as f itself differentiated. So antiderivative is not unique. If you find one, you actually find many of them. So if you find a function just plus c, any c, that's antiderivative too. Okay, so the following table shows all those basic antiderivative results or integral results. We just call them as integration formulas, basic integration formulas. Let's take this one as an example. Since we know derivative of sine equal to cosine, therefore we denote it as this, which say integral of cosine equal to sine, or antiderivative of cosine is sine, of course with the plus c. All right. So those are the basic formulas we're going to use to find the antiderivative function or to evaluate the integral expressions, integrals. There are also two rules we need. All right. So first, we said if there are two functions f and g in a sum or difference, integral of these two, or the whole thing, is the same as the integral of each separately with the same plus, plus, or minus, minus, right? So basically integrate through. In a sum difference, we can just integrate each individual term. Two terms or even more, we just integrate through. The second rule says the constant factor, like k, in a product can be just poured out. In terms of integration, we just say we just integrate the function part. Just pour out the constant. Let's see this is a simple example, see how we apply these rules. So first, we're going to see there are three terms involved. So according to the first rule, we're going to just integrate through. We can integrate this first term. We can integrate the second term. And the third term, just integrate through. Just put the integration through. Now I'm just showing how this rule works. Later on, we're not going to write this step. We'll just go ahead and integrate each and every one right away. This is just to show how the rule in play. So now the first integral, the 6 is like the k in this product, right? So we can pour out the 6. So just copy down the 6 or pour out the 6, and then integrate the part involving x only. The second term 2. Just pour out the number 2 in the front. The last one, we can leave it there because we have a formula for constant. Okay, so far we saying how we apply these rules to break through, to distribute the integration signs through, basically, right? To completely finish up the problem, we're going to apply individual rules or formulas, rather. So first we need the power. See, this is third power. We're going to use the power rule, like here. Okay, the power rule says if you integrate the nth power, you can have 1 over n plus 1 times x raised to n plus 1. So with that, it'd be 1 over 3 plus 1 x raised to 3 plus 1. Oh, the second one would be 1 over, oh, there's no more integration sign. Once we apply the formula, there will be no more integral sign. So 1 over n plus 1 x raised to n plus 1. And integral of a constant be the first formula here, be constant times x. So simply 5 times x, and then we have a c for all. Strictly speaking, we would have a c for each every integration formula we apply, but all the c's are supposed to be arbitrary constants, so we could just combine them into a single one. Okay, you don't need the 3 separate c's. And finally, you can simplify it as a 6 over 4x to the 4th power minus 2 over 3x to the 3rd power plus 5x plus 1c. Okay, so this simple example shows you how we use these integration rules, integration formula, to evaluate the integral. Let's see more examples. So the first one here is 3 times the square root of x, radical. And we have a radical here, we have a radical here. We don't really have a formula for integration formula for radical. We actually have power. And good news is radical is a power. So we're going to first turn this into half power, turn this into third power. All right, so we have power formula. So this is half power. The cubic root on the bottom is a third power. Now, algebraically, it's the same as a negative third power if we move it to the top. Okay? You cannot have anything in the denominator because we don't have any formula for fraction with the things on the bottom. Simple power, let's put it this way. There's some special fraction, but not this one. So let me show you. See, if you do have 1/3 power, you cannot integrate that directly. There's no formula. You must turn that into a power in the numerator to be able to apply the power formula. If there's some other formula that can apply, that's a different story, but we don't have any other formula for power alone, single power alone in the denominator. Okay, so anyway, algebraically we turn every turn into a power, and then apply rules, formulas. First, I get the rule, right? There are 2 terms in the difference. Basically, we can integrate respectively, and with the constant 3, we can copy it down. So we just go ahead, apply those rules directly. 3 copy down, and then you integrate the power, that'd be 1 over power plus 1 x power plus 1. The second term is the same, power, negative 1/3, which is power, x raised to negative 1/3 plus 1 power, and with 1c. So this basically is integration done. You can simplify it more. Let's see, 1/2 plus 1 is 3 over 2. You flip 3 over 2 over 3, so 3 cancel out, actually end up with just 2 there. 3 over 2 with the power, and 1/3, negative 1/3 plus 1 is 2/3. 3 over 2. If you flip it, all right, this be the answer. Next one. Again, we don't have an integration formula for this type of a fraction. We cannot individually integrate, for example, the square on the bottom and this guy is on the top. There's no such rule. So what we have to do is to prepare it by using a termwise division. So we're going to divide each every term on the top by x squared on the bottom. So first is just preparation. The first term divided by x squared be 5 times x to the second power, because we cancel out the 2. 2x squared divided by x squared would be 2. 4x divided by x squared would be 4 over x. All right, so this is how we prepared it. And you ask, should we keep the x on the bottom? Well, shouldn't we rewrite it as x to the negative first power as a power? Well, algebraically, yeah, we can do that. It's just that for power, pay attention. If it's a negative first power, the power rule doesn't apply. There's a special formula for power of -1. In this case, we usually keep it as 1 over x. So if the power is -1, write it as 1 over x, and the answer is logarithmic function, rather than power, another power, n plus 1. Cannot have n plus 1, because the formula, if n is -1, denominator is 0, so the second formula fails. Okay, so when it's negative first power, leave it as 1 over x. There's a special formula for that. Okay, and from here we just apply appropriate formula. Copy down the 5. 1 over 2 plus 1 is 3. Constant times x. 1 over x is log. So copy down the 4 and have log plus c. Strictly speaking, we should have absolute value of x there. Usually, we don't use absolute value signs with the understanding that the x can only be positive. Okay, so this example just shows, sometimes you have to rewrite, you have to prepare your integrand so appropriate formulas can be applied. See here, integral of e to 4x minus sine 6x. We just basically find the appropriate formula. Let's see. Exponential. Where do we see exponential? I see. Okay, here's the exponential. I'm going to modify this formula. E to ku du as 1 over k e to ku plus c. All right. And those guys too. If you have a k times, you have a 1 over k in the back. For example, cosine ku equal to 1 over k. Usually you don't just see u there, you see a number of times. That's why cosine ku plus c. All right. So this is true for sine, cosine, any trig. You can totally just replace by k times u inside each trig, and on the right side just have 1 over k. It's more convenient, more common to have constant times variable, right? This is because of different degree technique that we'll explain in details later. But now just know you can have a constant in there. So here we have a constant 4 times according to our formula. As a matter of fact, in many integration table, you see, for example, here you see ku instead of just u itself. So this table happens not to have the k in the front, right? So according to the modified formula, this would be 1 over k e to kx. Or the second one, again the k version. Integral of sine, first integral of sine is a negative cosine, check out. Integral of sine is negative cosine. If you have a k times u instead of just u there, all you do is just have 1 over k in the front. So we're going to have, first of all, the negative, 1 over the k cosine kx with the plus c. All right, simple enough. Okay, so final answer. Next, integral of 5 divided by square root. This is very complicated, very special radical. We cannot rewrite it so that simple rules can be applied. So it's a special one. So let's find the special formula for this one. So if the constant on the top is fine, we don't worry about that. It's 5. We can always copy down the 5. What's important is the radical, the fraction here. So let's see what formula we have. This kind of fraction involving radical on the bottom. It's a number 4 minus x squared. Let's go check our available formulas. Well, if you look carefully, it's this one. So a squared is like a 4. Okay? So the answer is inverse sine u over 2, because a squared is 4, therefore a is 2. With this formula, we see it's going to be inverse sine x over 2 plus c. All right, just apply the formula directly. Let's see more example. Okay, so here this just to show you that what you do with the stuff in the denominator again, you cannot. What I want to emphasize is that you cannot directly apply power formula for the third power in the denominator. You don't just say, hey, this is 1 over 4 whatever in the denominator. I cannot do that. You have to rewrite as x to the negative third power minus 3 times second power. One more thing too, you cannot just say, hey, you have a square on the bottom, then should it be log? Just because you stuff in the bottom, it's not correct. Log is only for first power on the bottom. Just first power only. This will be log. Anything else, you have to do things differently. You don't just simply get log just because it's on the bottom. Very common mistake people make. But anyway, so in this case, we're going to turn power, move the power to the top, and then apply formula from here. Copy down the 2, 1 over negative 3 plus 1, x to negative 3 plus 1 is negative 2. 3 times 1 over negative 2 plus 1, be negative 2 plus 1, be negative 1. Just simplify it right here. And plus c. And you can simplify further, but that's not important. Okay, just sure apply formula here correctly. Integration formula is correct. Okay, with this example, I really want to show you just because you see structure expression in the bottom, you go ahead apply log, or when you have a fraction, you cannot directly integrate the bottom. So like the first one, 2x, very common mistake. You cannot just say, oh, I have 1/4 x to the 4th power on the bottom. Wrong, cannot do that. All right, finally, let's see this integral. So here I have x squared times x plus 2. What I want to remind you is you cannot integrate right away here. You cannot integrate x squared and the x squared plus 2. Cannot do that because there is no such like a product rule. Okay, so you must multiply through as a 4th power and 2 times square. Have a powers, individual powers in a sum or difference. Now you can apply integral power for each power involved. So it'll be 1 over 5. Remember n plus 1? 5. And the copy down to 2, 1 over 3, x to the 3. 2 plus 1 is 3. Okay, so this will be the final answer. Right, remember, when you have a product, you cannot integrate right away. You have to break it up. You have to multiply out. All right, let's stop here.